In Cycle 2, Lesson 9, we're going to review something that you learned in grade 10, but my experience tells me is that a lot of people haven't become masters of factoring yet. And to be honest, you really should become an expert factorer if you hope to make things easier on yourself in this course. So anytime you can spend practicing factoring, getting it so that it comes naturally to you is going to be time well spent, and you will be very thankful later that you did so. So, first part of this lesson is to run through some different types of factoring that you have seen before, but you may have forgotten. So first and foremost, and I definitely mean this, is common factoring. Common factoring is the very first type of factoring that should always come to your mind when you're asked to factor. So in other words, everything you're given, if someone's asking you to factor it, you should check for a common factor. So it's finding out what can go in. If something can go into every term, then you should divide it out. So, for example, if I got 14x squared plus 21x, I check to see, is there some number that goes into both 14 and 21? Pardon me. So I'm looking at the 14 and the 21. I'll just focus on them for now. So something that just goes into the number part, the coefficient. And yeah, there is. 7 goes into both 14 and 21. And then I move on and I try to find out, is there anything that goes into both the variables, the x squared and the x? And of course, yes, whatever the lowest exponent is on a variable, that would be the common factor for all variables of the same letter. So for x squared and x, the lowest exponent is the 1 that's assumed to be on there. So x to the 1 would be the part of my common factor. So remember what we write out front here? This is the GCF, greatest common factor, GCF for short. So we try to find the GCF, the greatest common factor that goes into each one of the terms, and then we divide it out. So we take 14x squared and divide it by 7x. 14 divided by 7 gives 2. X squared divided by x gives x. And then I take 21x and divide it by 7x. So I divide each of my terms by the GCF. 21 divided by 7 equals 3. X divided by x, those cancel out. So these go away. If they're the same, we call it canceling out. And if that's the only thing there, if there's only x divided by x, it wouldn't be 0. Canceling out means going down to 1. All right, but there is also that 3 already there, so it would be 3 times 1, and my answer would be 3 still. So that should be always the first thing you check for. And so I'm going to really emphasize that in this lesson. Even when I know that it's not the case, I'm going to keep reminding you to do that. Another type of factoring, one of the types for quadratics, is called a difference of squares. You find the square root of each perfect square, and then you put them in a bracket, making one an addition, the other subtraction. So the first thing is recognizing a difference of squares. You're looking for a perfect square. So 25 is a perfect square. The square root is 5. X squared is a perfect square. The square root is x. And 36 is a perfect square. The square root is 6. And you're looking for their minus sign between them. It has to be a minus sign. That's what makes it a difference of squares. Difference indicates subtraction. If you've got those three factors, 2 perfect squares and a minus sign between them, then you can always factor it. But first, I'm going to look for a greatest common factor. Is there some number that goes into 25 and 36? No, there's no number that divides into both of those. So there's no greatest common factor, but I checked for it. And I'm going to keep reminding you to check for it. So there's no common factor. I go on and do my difference of squares. So again, square root of 25x squared is 5x. Square root of 25 is 5. Square root of x squared is x. And I write that down twice, like one in each pair of brackets. And whatever the first number is goes at the front of the brackets. And then I take the square root of 36. That's 6. I write that at the back end of each pair of brackets. And then as far as the middle signs go, you're always going to have one be positive and one be negative. It doesn't matter what order you put them in, but you have to have one be positive and one be negative. The reason why this works is because if I was to do FOIL on this, first times first would give me 25x squared. First, or outside times outside, 5x times negative 6 would give me negative 30x. Inside times inside, 6 times 5x would give me positive 30x. And last times last, 6 times negative 6 would give me negative 36. When I collect my like terms, then you can see that I've got two like terms in the middle. They're the same number, opposite signs. They cancel out. All I'm left with is 25x squared minus 36. And that gets me back to what I started with. So difference of squares. You recognize it by having two terms with a minus sign in between them, and each term is a perfect square. A simple trinomial, just one that doesn't have, you find two numbers that multiply to give the last term and add to give the middle term. I call them, these are ones that have no an a value of 1 or no a value. You recognize it as because the a value is 1, which means you don't see it there. So there's assumed to be a 1 there, right? So if there's nothing in front of the x squared, it's a simple trinomial. You want to add to give the second term, and you want to multiply to give the third term. So you generally start, not generally, you should always start with the third term, because that'll give you a limited list of factors. So for example, 6, I could get that by doing 6 times 1 or 2 times 3. Those are the only options. So I don't have to hold a lot of options in my head for this one. And then I think, all right, of those pairs of numbers, 6 and 1, 2 and 3, do either of those add or subtract to give me my middle number of 5? Well, 2 plus 3 does give me 5. But 6 minus 1 also gives me 5. So maybe I'm not quite sure what's going on yet, right? So I would normally write it. I'm going to erase these plus signs here for a second. I would normally try it out. So what if, let's erase everything. What if I thought it was the 6 and the 1? So maybe I think 6 and 1 is going to work. The last thing I have to consider is the signs. In order to get a positive 6, I'd have to have two signs the same. So they either both have to be positive, which would give me a positive 6, but when I add them, I'd get positive 7. Or they'd both have to be negative. Again, negative 6 times negative 1 gives positive 6, but when I add those, I get negative 7. There's no way I'm able to make these signs work for doing 6 and 1. So I can rule those out, and then I go back and try 3 and 2, yeah. And positive 2 times positive 3 gives me positive 6. Positive 2 plus positive 3 gives me positive 5. So that one, that does work. So everything has to click together. It's not enough to have it mostly work but not work out. I have to make the numbers multiply to give the last number, add to give the middle number, and the signs have to work as well when I do my multiplying and adding. Now, the complex trinomial is one where the coefficient, the number in front of the x squared isn't 1. In other words, a is not equal to 1. Okay? So a is not equal to 1, so maybe it's 2 or 3 or negative 5 or something like that. We always look for a common factor first. And I didn't mention looking for a common factor first in the simple trinomial because I forgot to be honest. In a simple trinomial, you won't find a common factor because a common factor, there's no x term no x in the last term, so I won't be able to take an x out. And if there's no number in front of the x squared, no a value, I'm not going to be able to take a number out. So that is a case where a common factor won't work. But you're always going to look for a common factor first if you do have an a value. And if there isn't one, then you can do trial and error, or you could do decomposition or other methods that you've learned in the past. I usually go for trial and error simply because I find it the fastest, but I don't have I know it doesn't matter to me what you use as long as you get it right. So here's how I'd approach this one. Let's get rid of this answer so we don't have it distracting us. 2x squared minus x minus 6. So first thing I do is look for a common factor. Is it possible that I could take 2 out of everything? Because 2 could be taken out of here and out of 6, but no, there's no 2 or 4 or any number in front of the x that would let me take 2 out as a common factor. So common factoring, I tried it, but it's not going to work here. So what I like to do, again, I do trial and error. Here's how I set it up. I just sort of use this little box method to make things, to organize my thoughts. So for this first term, the 2x squared, I think of two things. I think of multiples of that would give me 2x squared. So obviously for the 2, I'm going to have 2 times 1. And for the x, I'm going to have an x times x. So if I do 2x times 1x, I'm going to get 2x squared. And in fact, that's my only possibility for my x squareds, right? So that's what goes in the first part of this box. So I'm going to do a factor. Basically, I'm doing 2 factors. I'm doing a factor on the top and a factor on the bottom, just so you know where I'm going with this, if you haven't seen it before. Then I think about factors of 6. Don't worry about the negative sign for now. Just think about factors of 6. 6 and 1, 2 and 3. Sometimes you're going to have more factors. Sometimes you're going to have less. This one doesn't have very many. I always start with the factors that are closest together. More times than not, the factors that are closer together are the ones that are going to be the ones we want. So 2 and 3 are the factors that are closest together in this case. So I might write 2, 3 like this. 2 times 3 will definitely give me my 6. Then when I'm trying to figure out this middle number, I'll highlight that one in orange, I need to get a negative 1 out of this. So what I do is it's not cross-multiplying, but I multiply the corners together to get some numbers out of this. So if I multiply 2x times 3, that's going to give me 6x. And I'll just write it underneath for simplicity. If I do 1x times 2, that gives me 2x. These numbers here are the ones that I have to be able to add or subtract together in order to get the negative 1x in this case. 2x plus 6x is 8x, 2x minus 6x, or vice versa, is 4x, whatever the signs are. There's no way I can combine 2x and 6x to get negative x. So what that tells me is that I haven't got the right combination of numbers right now. So it's back to the drawing board. So instead of having 2 and 3 in this order, maybe I'll reverse them. Maybe I'll put the 3 on the top and the 2 on the bottom. They're still giving me 6 when I multiply them together, but I'll get a different combo when I multiply the corners together. I'd get 4x when I do 2x times 2, and I'd get 3x when I do 3 times 1x. And I can combine 4x and 3x to get a negative 1x as long as I have the signs right. So I think I'm on to something here. I think I've got the numbers in the right order, but I still have to worry about the signs. So as far as the signs go, I notice that this is a negative 6. The only way I'll be able to get a negative sign in front of the 6 is if I have one positive number and one negative number multiplying together. So either the 3 has to be negative or the 2 has to be negative. So which one is it going to be? Well, looking at this negative x here, if I make this a negative 4x, when I add it together, negative 4x plus 3x will give me negative x. So backtracking, the negative 4x came from doing the 2 times 2. So if I make the 2 negative, then that would give me negative 4x, and that's going to make everything work out. That means the 3 has to be positive. So if I read sideways, this would be one factor, which would be 2x plus 3. And this would be x minus 2. Those are my 2 factors, and as you know, the answers are already there, but that's how you can get it. Now, I took a minute explaining it, but if you use this trial and error method, you can zip through different possibilities really quickly, and generally I find that to be the fastest. As I said, decomposition, that's all right. I don't have a problem with that. I just don't find it as quick, but whatever works for you. Of course, we can use the quadratic formula anytime. I just don't recommend using it all the time. The only time you should use the quadratic formula is if you've looked something over, tried to factor it, and found that you can't think of any factors that work. And so if that's the case, then yes, by all means use the quadratic formula. And we've already used it in this course. It has to be, quadratic formula does not put a quadratic in factored form, which just tells you what the zeros are. And so it's got A, B, and C, as we already saw. So you have to have it in standard form, and then you plug in the A, B, and C values into this formula and just crunch the numbers. But you have to be careful about following order of operations and keeping signs correct, and it just takes longer. So don't use it unless you have to. So here's a few examples. Factor the following. Okay, so I glance at it, and immediately I'm drawn to the fact that it's a trinomial with an A value, and I always think common factor first if possible. So out of 14, 21, and 7, is there a common number that goes into all of them? Well, yeah, of course. 7 goes into all those terms. And as far as x to the 4, x to the 3, and x goes, then yeah, x goes into all of them. X is my lowest exponent. So if I divide, that's my GCF. Let me just pause there for a second. So 7x is my GCF. Now, if I were to divide 14x to the 4 by 7x, 14 divided by 7 is 2. X to the 4 divided by x is x to the 3. And then if I move on to the next part, positive 21x cubed divided by 7 gives me plus 3, and x cubed divided by x gives me x squared. And then when I do the next part, negative 7x divided by 7x, well, negative 7 divided by 7 is negative 1. X divided by x cancels out, and that is as far as I can go for common factoring. So I've common factored it to the best of my ability. Now what I have to always do, though, is look at what's inside the brackets to see if there's anything more I can do. So can I factor this any further? Well, it's not a quadratic, so I can't use difference of squares or simple trinomials or complex trinomials. I don't have any techniques to go any further. So because of the fact that I've got this cubed still here, that means that I'm done. I'm not going to be able to go any further on my factoring for that one. So that would be my answer there. And again, it's the exponent 3 that really means that I'm at the end of the line there. For this one, again, first thing I always check is common factors. Can I take something out of 16 and negative 28? Absolutely. Or can something go into both of them? Absolutely. 4 goes into both of them. I think that's the biggest number that goes into both of them. And then if I look at the a squareds, my lowest power there is I got a squared and a cubed, so my lowest power there is a squared. And if I look at my b's, I got a b cubed and a b. My lowest power there is b. So getting the common factors are really simple if you know what to look for. For the numbers, you just look at the what goes into all of them. For the powers, you just look for the lowest exponent. Now, then I'm going to go through and I'm going to divide each of these two terms by my GCF. So if I divide 16 by 4, it's going to highlight to show where I am, sorry. If I divide 16 by 4, I get 4. If I divide a squared by a squared, they cancel out, so there's no a's left. If I divide b cubed by b, which is assumed to be b to the 1, I'll subtract the exponents and I'm left with b squared. And I can always check my answers too. I could try multiplying this back out. 4 times 4 is 16. A squared times nothing is a squared. B times b squared is b cubed. That would take me back to what I started with. Then I move on to the next term, which is the negative 28 a cubed b. So negative 28 divided by 4 is negative 7. A cubed divided by a squared is just a. B divided by b cancels out. And I could check that the same way. And that would be my factoring so far. And then again, I always check what's inside my brackets to see if there's anything else I can do. And in this case, 4b squared minus 7a, no, it's a kind of a quadratic, but it's not really. I got the two different variables. You just have to recognize that that is all you can do. We're done in this case. For example, 2, I recognize it's a quadratic. I think about common factoring, but a quick glance lets me know there's nothing to be common factored in a part. I do check to see if it's a difference of squares. It's definitely, obviously, got a minus sign in between them. X squared is a perfect square, so is 49, square root is 7. So that's the difference of squares, can be quickly factored. I'll put an X at the beginning of each bracket. I'll put a 7 at the end of each bracket. I'll put a plus sign between one and a minus sign between the other. If I was to do FOIL on that, I'd get back to x squared minus 49. That's all there is to that one. For B part, again, is there a common factor? Well, does something go into 16 and 25 other than 1? No. A squared and y squared? No, no common factors. But it does look like a difference of squares. Minus sign. So that's two terms with a minus sign between them. 16 is a perfect square, as is x squared, so that can be square rooted. 25 is a perfect square, as is y squared. That can be square rooted. So this is a difference of squares. Again, take the square root of the first term. So square root of 16 is 4. Square root of a squared is a. Put that in front of both the beginning of each bracket. Square root of 25 is 5. Square root of y squared is y. Put that at the end of each bracket. Put a plus sign in one bracket and a minus sign in the other. And again, that's all you have to do. Factor the following. So these ones are trinomial quadratics. Again, quick glance lets me know there's no common factor, especially since there's no a value. There can't be a common factor if there's no a value. But I think about it. So this is one where I just look to see, is there, what's going to multiply to give 24 and add to give 2? So I know it's going to start with an x in each bracket, but factors of 24 are 24 times 1, 12 times 2, 8 times 3, 6 times 4. I think that's it. So I want to think about what's going to work. Usually I think about the ones that are closest together first and work out from there, so the 6 and the 4. I know that I have to have one of each for when I multiply them together, one positive, one negative, for when I multiply them together to get a negative 24. And just, thinking about it a little bit, it would make sense to have a negative 6 and a positive 4, because that would definitely multiply to give negative 24. And when I add them, that would give me negative 2. So I've hit upon the right combination. Here's one that has an a value. So again, when I think about the common factors, 4 goes into itself and 28 and 48, so definitely I can and need to take that common factor of 4 out. I can't take an x out because there's no x in the last term, is there? But if I take 4 out as a common factor, I'm left with x squared plus 7x plus 12. So I got my common factor out, but as I mentioned above, I always need to see, can I go farther with what's inside the brackets? And in this case, I think I can. All I have to do is find two numbers that multiply to give 12 and add to give 7. So again, factors of 12 are 12 and 1, 6 and 2, 4 and 3. And hopefully 4 and 3 sort of that seems like a good possibility to you. So as far as inside the brackets goes, I can break that down further to x, at the beginning of each. If I do 4 and 3, both positive, that would multiply to give 12 and add to give 7. What about the 4 that was out front? I just write that down again. And that's not optional. It has to be written down again, because each line has to be equal to the line above it. If I leave this 4 out after taking it out at first, then this third line would not be equal to the line above it. So it's not optional. I have to keep writing that 4 down no matter how many lines I do. Okay, factor the following. So I've got an a value of 2. So I look for a common factor, but I quickly see there's no common factor. So this is a complex quadratic that I need to do whatever method I'm going to use on. I'm going to do a little trial and error. So factors of 2m squared would be 2m and 1m. Those are my only possibilities. Factors of 1 are 1 and 1. That makes it pretty simple, doesn't it? Because then when I do my diagonal multiplication, I'll get 2m and I'll get 1m. That's what has to add together to give me the middle term, and 2m and 1m does go together. Everything's positive signs, so these will both be positive. And so my factors are 2m plus 1 and m plus 1. And that's what I mean about being quick with that. That's a pretty quick way to do it. 12x squared minus 7x minus 10. Again, I look for a common factor, but I don't see anything that's a common factor in this one. So I'm going to set up my little box again. And I got more options for 12 than I did. I could do 12 and 1, I could do 6 and 2, I could do 3 and 4. Again, I like to start with the ones that are closest together and work outwards. Likewise, for 10, I'd go 5 and 2. Now, I could just randomly put numbers in and see what I get. But I can also just try to, since I know the process, I could sort of mentally play with them before I write them down and see if anything works. I think... Let's see, 2. I don't know if this is going to work because I haven't actually worked it out, but what if I put it this way? This one seems maybe more promising than putting the 5 first. It might not be it. I haven't worked it out. I'm just talking and thinking as I go along. But let's see what we get. 3 times 5, 3x times 5 is 15x. 4x times 2 is 8x. If I do 15x minus 8x, then I could get 7x. So I think that is what I want. I think I've hit the right combination. But again, we got these minus signs here. So the minus sign in front of the 10 tells me that one of the numbers, either the 2 or the 5, has to be negative. To help me decide which is going to be negative, I can look at this and say, okay, I need a negative 7. So in other words, if I make my 15 negative here, when I add these two together, that will give me a negative 7. So where did the 15 come from? It came from the 3 times 5, didn't it? So to backtrack, that means that I should make my 5 negative so that my 15 would then become negative, so that this could then become negative. So it's a step-by-step backtracking. But now that I've figured that out, then I know that the 2 has to be positive, and these would be my 2 factors. It would be 3x plus 2, this one, and it would be 4x minus 5. This one, right? So again, trial and error, whatever you want to use, doesn't matter. This last one, does it look like it's got a common factor? Nothing goes into 4, 12, and 9. There's no x in the 9, so no common factor. I could do trial and error. But there's one other thing I can always look out for, and it's called a perfect square trinomial, which is what I think this one might be. And perfect square trinomials are like difference of squares in that the first term needs to be a perfect square, which this one is. The last term has to be a perfect square, which this one is. And the middle term has to be the square root of the first term times the square root of the last term times 2. So in other words, the square root of 4 is 2, times the square root of 9, which is 3. So 2 times 9 is 6, and then double it gives me 12. This is definitely a perfect square trinomial. A perfect square trinomial has come up before in this course. It's one that's got 2 factors which are exactly the same. So since I recognize this one as a perfect square, I know how it's going to work. I'll take the square root of the first term, so 4x squared square rooted is 2x. Put that at the beginning of each factor. Square root of 9 is 3. I'll put that at the end of each factor. since this is, I'll take the sign of this middle term. Since this is positive, that means that both of these have to be positive. If this could be exactly the same except have a negative in the middle, and if that was a negative, then each of these would be negative. They're both going to be exactly the same, but it just depends on what that sign of the middle term is. So I got two terms exactly the same. I can write it as 2x plus 3 all squared since they're exactly the same. So a perfect square trinomial always gets you the exact same, two of the exact same factors, and again, you recognize it the way I just explained. If you missed any of that, I know I went through it quick, but again, if you missed it, the whole point of me doing the video is that you can go back and listen to it again. You can pause it and think about it, but that's a good way to recognize perfect squares. So more than anything, you need to be good at factoring, as I began this lesson with. And the way you're going to do it is you're going to do it by practicing, and more practicing. So good luck with these questions. Let me know if you have any trouble.